Math 1314, Tyler Junior College, Section 2.6, Combinations of Functions, Composite Functions. The Algebra of Functions, Part 1. It is time to start building new functions. As I mentioned, I believe in the first video, there are 5 things we're going to do to build new functions. 4 of them are on the board. Suppose f of x and g of x are functions with domains of df and dg respectively. So df will represent the domain of function f, dg will represent the domain of function g. We are going to define 4 new functions. The intuitive thing is to do the same thing we do with numbers, add, subtract, multiply, and divide. And that's exactly what we're going to do. The first new function we're going to define is called f plus g of x. Now I want to clarify that this thing technically is not an addition problem. This is the name of a function. This function's name is f, this function's name is g, this function's name is f plus g. But its name tells you how to build it. To find the function f plus g of x, you simply take f of x and add g of x. It almost looks like we're doing a distributive property thing, except we're not. Namely because there is no multiplication implied here. Function notation doesn't mean multiplication. This is a definition. The function f plus g of x is defined as f of x plus g of x. Now, the others will be defined similarly, but I want to discuss the domain real quick. When you add 2 previously existing functions, each one may have their own domain issues. We saw an example of this in the last function in the previous video. In order for x to belong to the domain of f plus g, it has to be able to go into both f and g separately. In other words, it has to belong to each of their domains. So what this means is that the domain of f plus g of x is the intersection of these 2 domains. Because an input has to be able to go into each function separately before we can add the outputs together. I guess if we wanted to use the same notation, we could say the domain of f plus g is the domain of f intersect the domain of g. I think I'll leave that up there, but the remaining of them I will write in words. So how do we define f minus g of x? Again, this is not really a subtraction problem, it's the name of a new function. Hello, my name is f minus g of x, but its name defines how to build it. You take the first function f of x, the second function g of x, and you subtract them. Again, looks distributive, but it's not. This is one function, its name is f minus g. This is how you build it. So what about the domain? Well, again, in order to go into this new function, I have to be able to go into both of the original functions. That means that the domain of f minus g of x is also the intersection of the 2 functions. Not to sound like a broken record, but in order to go into this function, I have to be able to go into both of these first. I'm not sure about you, but normally after addition and subtraction comes multiplication, so I'm not quite sure what this is doing here. Let's fix it. The third new function is f times g of x, but to imply the multiplication, we're just going to write f next to g. You can read it fg of x, but it means f times g of x. And again, this is the name of a function. Hello, I'm a function. My name is f times g of x. My name tells me how to build me. To find f times g of x, you multiply f of x times g of x. And guess what the domain is? Just like before. In order to go into the new function, you must be able to go into the individual functions separately, which means the domain of f times g of x is still the intersection. And at this point, you're probably like, I get it. The domain of the new function is the intersection of the domains of the previous functions. Yes, but this last one brings up a new issue. Because this last one is creating something that did not previously exist, something that invokes another domain issue. The quotient of 2 functions, f divided by g of x, or f over g of x. This is a single function. Its name is f over g, or f divided by g. But its name tells you how to build it. To build f over g of x, you put f of x over g of x. And now we've just created a new domain issue where there was not one previously. As in the three previous combinations of functions, in order to go into the new function, I still have to be able to go into the two original functions. But now, the second function is in a denominator. And as previously stated, if there's a denominator, that invokes a new domain issue. So what's the domain of f over g of x? This one's a little trickier to write symbolically, but I can write it as an intersection. It is the first function's domain intersect the second function's domain, but it's also intersect something else. It's intersect the set of all x's such that the denominator, g of x, is not equal to 0. Don't let this symbolism throw you off. All this is saying is if there's anything that makes the denominator equal to 0, you have to remove it now. Because there didn't used to be a denominator, now there is. This may look a little complicated, but I promise you it's actually pretty easy. Building the new functions is just a matter of doing things that you probably already know how to do, as we'll see in the next video. And in some cases, finding the domain is ridiculously easy. The only real issue is when you create a denominator that didn't used to be there.